Hi everyone! Today we're going to study derivation of equation of the ellipse with center at origin and vertex on x-axis. First, let us define ellipse. An ellipse is the set of all points in a plane such that the sum of its distances from two fixed points in the plane is constant. The fixed points are called foci, plural of focus of the ellipse. Here we have 2 points arranged horizontally, and we consider this as the foci of the ellipse. Let us draw now the ellipse. Here we have the ellipse. The line through the foci is sometimes called focal axis. Here is the line, and this is the focal axis. The point on the focal axis, midway between the foci, is the center. Here is the center. The points where the ellipse crosses its focal axis are the vertices. So we have 2 vertices. This is the first vertex, and this is the second. The line segment joining the 2 vertices is called major axis. This line segment in red is the major axis. The line segment through the center, perpendicular to major axis, terminating at the ellipse, is called minor axis. This line segment in green is the minor axis. Now let us define eccentricity. The eccentricity, denoted by E of a curve, tells us the amount of roundness of that curve. Take note that the eccentricity of circle is 0. The eccentricity of parabola is 1. The eccentricity of ellipse is between 0 and 1. And normally, you will see this symbol in the books. E is between 0 and 1. Take note that a small eccentricity indicates that the ellipse tends towards being circular, whereas an eccentricity close to 1 indicates that the ellipse is elongated. Here now is the ellipse with center at origin and vertex on x-axis. Again, our coordinates for the origin is 0, 0. Let us denote the vertices to be V and V prime. We know that the line segment connecting these 2 vertices is called the major axis. Let us denote this major axis to be 2A. In that case, we can now write the coordinates of the vertices respectively. So this V here has the coordinates A0, and the V prime is negative A, 0. Let us now plot the foci, denoted by F and F prime. The line segment connecting these 2 foci, let us denote this to be 2C. In that case, we can write the coordinates of the foci respectively. For this F, we will write C 0, and the f prime is negative C 0. Now, these points B and B prime are the points where the ellipse touches the y-axis. The line segment connecting this B and B prime is called the minor axis. And we let this to be equal to 2b. In that case, we can now write the coordinates of the points B and B prime respectively. For the B, the coordinates 0, B, while the B prime 0, negative B. Now, let us pick one point of the ellipse denoted by P and the coordinates xy. This point represents all the points of the ellipse. Now, the distance of the first focus to that moving point and the distance of the second focus to that moving point is measured. By definition of ellipse, the FP plus the F prime P is always constant. It's equal to K. If this moving point is going around and stop at the vertex, we can deduce that the value K is equal to 2A, which is equal to that major axis. Then, we can now write FP plus F prime P equals 2A. Using the distance formula, we can now write the distance between 2 points respectively. This FP distance is now the big square root of x minus c, the quantity squared, plus the y minus 0, the quantity is squared, plus the distance f prime p is equal to this big square root, the x minus the negative c is x plus c, and the quantity is squared, plus the square of this y minus 0, and equal to the right side, which is 2a. We can simplify these portions by simply writing y square. And then, let us isolate one radical. It means we're going to transpose one of the radicals on the right side. Let's say this one, we will transpose, so from positive, it becomes negative. To simplify further, let us square both sides. For the left side, if we square this big radical will be cancelled. So only this radicand here will come down. While the right side here, we're going to square this, and then the answer will be the square of 2a will be 4a squared. And then the second term here is the product of 2a and this big radical multiplied by 2. So we have now negative 4a times this big radical. And the third term is the square of this radical. So we will have to cancel that big radical sign. So this is now plus. And the radicand here comes down now. We can see here that there is y square on the left side and y square on the right side that we can cancel out. After that, let us expand the squares here and also here. So the square of x plus c becomes x squared plus 2cx plus c squared. When we expand this, it becomes x squared minus 2cx plus c squared. Observing the left side and the right side, look at the x squared here and also x squared on the right side. We can cancel those x squared. Likewise, there is c squared on the left and also c squared on the right. We can cancel those c squared. And from here, let us simplify by isolating this big radical. It means to say, this negative 2cx we will transpose on the left side. So from negative, it becomes positive. But on the left, there is positive 2cx, which means we can combine the two terms. It will be 4cx later. And this 4a squared, we will transpose on the left. So we have now 4cx minus 4a squared equals, the right side now is that radical alone. We can see here that all terms have the constant 4. Let us divide the equation by 4. So we have now cx minus a squared equals negative a with a big radical here. And then let us square both sides. The left side will be c squared x squared minus 2cx a squared plus a raised to 4 equals, the right side, when we square the negative a, it becomes positive a squared. When we square the big radical, it will go away. So only the radicand here comes down. And let us expand this x minus c squared. So we have now the x squared minus 2cx plus c squared. And the rest of the terms remains the same. Now, this a squared we will distribute to all terms of the grouping symbol. So we have now a squared x squared minus 2cx a squared plus a squared c squared plus a squared y squared. We can see now that there is negative 2cx a squared on the right side and negative 2cx a squared on the left side. So we can cancel these terms. What we will do is, we will put all terms with x and y together, and all constants we will put on the left side. So look at this term, the c squared x squared. We will transpose this on the right side, so from positive, it becomes negative later. Look at this a squared c squared. This is a constant. We will transpose this on the left side, so from positive, it becomes negative. So here we go. We have now a raised to 4 minus a squared c squared equals a squared x squared minus this c x squared, and plus we copy this a squared y squared down here. And then please observe that the left side, the terms have a common factor. That is the a squared. Look at these two terms. There is a common factor, and that is the x squared. So let us factor out the common factors respectively. On the left side, we pull out that a squared. So what remains is the a squared minus c squared. Here we factor out the common, which is x squared. What remains inside is the a squared minus c squared. Plus, we just copy this a squared y squared. Now, let us observe when it touches this B. From here, we can see that there is a right triangle here. This hypotenuse here will be equal to A. From this B up to the origin, this is of length B. And from the origin going to the focus, that will be length C. So by Pythagorean theorem, we say that A square equals B square plus C square. Thus, we can manipulate this to be A square minus C square. This A square minus C square that we can see here and here is equal to B square. So by substituting this value, we have now A square times B square equals X square times B square plus A square Y square. Let us simply interchange this B square to X square. And from here, we will divide this equation by A square B square. So it will result to 1 equals X square over A square plus Y square over B square. And when we interchange the right side and the left side members, we will have this X square over A square plus Y square over B square equals 1. This is the equation of the ellipse with center at origin and vertex on x-axis. There is a chord through a focus and perpendicular to the major axis that is called Lattice Rectum. Plural is Latera recta. Here is the first Lattice Rectum, and this is the second Lattice Rectum. Let us find the endpoints of the Lattice Rectum. The value of the x-coordinate is C. Let us substitute x equals C to the equation. So we have now C square over A square plus Y square over B square equals 1. By the Pythagorean theorem a while ago, we can deduce that C square equals A square minus B square. So this C square here, we will replace by A square minus B square. So here we go. From here, let us distribute the denominator to each term of the numerator. So we have A square over A square minus B square over A square plus this fraction we will copy here, and this is equal to 1. We will simplify the A square over A square into 1. And from here, this constant 1 and the constant on the right side, which is 1, can be cancelled out. By then, we are going to solve for y. Take note that this negative b square over a square is a constant. Let us transpose this on the right side. So this negative becomes positive. So we have now y square over b square equals b square over a square. Let us simplify further. Cross multiply this b square to the numerator of the right side. So we have now the y square equals b raised to 4 over a square. If we take the square root of both sides, we will have the value of y. So we have now y equals plus or minus b square over a. This is the y coordinate of the endpoint of the latus rectum. It means to say, this is the first latus rectum and the endpoints are c, comma, plus or minus b squared over a. For the second latus rectum, the endpoints are negative c, comma, plus or minus b squared over a, respectively. Now for the length of latus rectum, abbreviated by LLR, this is equal to 2b squared over a. Now, the eccentricity, denoted by E of the ellipse, is the ratio C over A. I hope you learned something from this video. See you again next time.